For section 3.8, we're going to cover compound inequalities in one variable. So we're going to talk about some of the set notation and for intersections and unions of sets. And I've got some notes already pre-written here where I have on this side we're focusing on the intersection, and the symbol for intersection is going to be what? It's a little upside down U right there. If we're talking about the proper set notation. And intersection is associated with the word and, meaning that it has to be part of both sets. It's elements, the proper definition of it is elements that are common to both sets. And then the other thing too is you want to be able to understand the union. Now the union looks like a U. That's the symbol right there. Every element that is given for both sets. And the operative word for this one is or. So that's kind of the focus on that one in particular, is or. So the union is kind of everything kind of thrown together into one big, kind of like a fruitcake, everything's there. Whereas intersections is what they both share in common. It's kind of like an LCD or a GCF. So for this first example right here, we've got set A and we have set B, some numbers there. And for A, we want to find what it's asking right here. That symbol is the intersection. So the intersection of A and B is what they have in common. What do they have in common? And so if we're going to do that, so A intersection B is going to equal, I'm going to use set notation to express it. This is example A, by the way. Do they have a 0 in common? No. Do they both have a 2 in common? Yep. So they have a 2. Do they have a 4? Yep. Do they have a 6? Nope. And so there you go. So they both share a 2 and a, so I circled the wrong thing there. They both share a 2 and a 4. All right, for example B, we're looking at the union. So A union B, we're going to use set notation again for that one. And A union B is basically everything. So we're just going to write all the numbers. So 0, there's a 1, there's a 2 in both those lists. Well, it doesn't matter if it's in both. There's a 3 in one of those lists. There's a 4. There's a 5. There's a 6. There's no 7, but there's an 8. And so there's the union. Notice the union is everything. It doesn't matter if they are common or not. We just kind of put it all together. And you don't want to put any repeats down, even though like there's a couple 2s, and there's a couple 4s. Just write down the 2 and the 4 once. All right. So for this one, now when it comes to inequalities, for compound inequalities, typically what you're going to want to look for are number lines that are kind of graphed like this. And I'm not saying it looks exactly like this, but you're going to have like a point here, you're going to have a point here, open or closed point doesn't matter. But we're going to talk about the x value is going to represent the space between. What do they both share? Okay, so it's going to look like that in a lot of ways. And that's going to be associated. You're going to see that a lot with and. So now when it comes to graphing these, we're going to go ahead and let's see, 2, 3, 4, 5. Oh wait, I want to include -1 in there, so let me start over, sorry. And for 4, we're going to do a close point. And for -1, we're going to do a close point, and then we're going to do the space that's in between there, right? And that shaded area there between those points, -1 and 4, that represents the x. All those represent x, and there's an infinite number of x values that it could equal in between -1 and 4. Even though it's a finite region, it still has an infinite number of possible answers. Right, for number 3. For number 3, we've got w is greater than or equal to -4, so I'm going to do close point there. You know what I'm going to do this time? I'm not going to put it on it though. I want to do it this way, right below it. So I'm going to do close point there, and then my vector is going to go this direction. And then for w is greater than or equal to 1, for that one, I'm going to do a close point starting at 1, and then our vector is going this way. So the part that they share, is the part that overlaps. That part that overlaps includes this region right here up to infinity, So going for infinity in that direction. That's what's going on there. And I should be writing my answer in interval notation. So in an interval notation, it's going to be 1, comma, in bracket because it's equal to, and positive infinity. And always use parentheses before or after infinity. Now number 4 is our first one that has or, which is another way to kind of talk about that is it's a disjunction. Disjunctions, conjunctions mean like kind of they're coming together. Disjunction means they're kind of doing the opposite, going apart. So let's go ahead and let me graph this. All right, so for t, the first inequality right there says t is greater than 5. So I'm going to do an open point at 5, and then the vector's going to the right, going greater. And then the other is t is less than 2, so we're going to do an open point at 2, and that's going that way. And too far. What happened? All right, so you got that. Now when we write this out in interval notation, we're going to have to write down kind of two different things here. We've got on that end, we've got negative infinity. So negative infinity, comma, 2. I'm going to close it with parentheses. And we're going to use the U symbol for union. And then I'm going to do 5, because 5 is on this side. I'm just looking at it from left to right. 5, positive infinity. And remember, you don't necessarily need that plus sign there. If it's positive, I just gotta do that just to make it clear. All right, number 6. This is same kind of stuff here. We're just solving it. So I'm gonna go ahead and solve both of these. Okay, so for number 6, this is an and, so we're looking at this as a conjunction or an intersection. Okay, we're looking at it like that. So let's go ahead and let's get some. I'm not gonna do this to scale. I'm just gonna pretend it's to scale. I'm gonna put the negative over here. So I got negative 1 2/3 right here. And I'm going to put positive 1 here. Never mind the scale of it. Just the negative is to the left of the positive. That's all I did there. And so for the first inequality, we've got u is less than 1. We got u is less than 1. I do this like that. And the other one, we've got u is greater than or equal, not equal to, u is greater than negative 1 2/3. So for this one right here, we're looking at the intersection here because it's an and right there. When we write that in interval notation, we're going to write down in parentheses negative 1 2/3, comma 1, and then parentheses around both ends of it. All right, for number 7, we're going to go ahead and solve both of these. Add 4 to both sides there, and so then I get 7. N is greater than 16, divided by 7, and you get n is greater than, I'm going to put 2 2/7, just so that we have a better idea where that falls on the number line. And then we're going to take away 3 from both sides. We got negative 2n is greater than or equal to 6. Divide by 2, negative 2, and since we're dividing by negative, we're going to flip that sign, but those cancel, so you get n is less than or equal to negative 3. Now this is or. So typically, when you're looking at an or, it doesn't always happen this way, but when you're looking at an or compound inequality, they somewhat look like this. They'll be like diverging graphs, be going away from each other. Those points could be either open or closed depending on what the signs are, but they kind of are going different directions. Whereas and, we're looking at what they both have. They both share that intersection part. So for this one, I'm not going to do this one to scale either. I'm going to put the smaller number on the left, negative 3. I'm going to put the larger number on the right. And this one's an or, so we've got n is greater than 2 2/7, open point there. And the vector's going to the right. And then n is less than or equal to negative 3, closed point there. Vector's going left. And then when it comes to the interval notation, start from left to right. So we've got parentheses negative infinity to negative 3, and we're going to close that up with bracket, and we're going to do, oops, not the u, we're going to do the intersection, and that's just an open point, so we're going to use parentheses, and we're going to do 2 2/7, comma, positive infinity. That's all you can do for that one. Number 8, we're going to take away 4 from both sides. I'm left with v is less than or equal to negative 1. And then for this one right here, I'm going to multiply both sides by 2, side by 2, and this side by 2. Those cancel off. I'm going to rewrite it. So now I've got v plus 3, because that's just 1, is greater than or equal to 8. Subtract 3 from both sides. Subtract 3, and you get v is greater than or equal to 5. And this is an and inequality. So and inequalities sometimes look like this. Points can differ, open or close, but they have this joining up. So let's see if that happens here. Not using good scale here, but that's okay. So I'm going to put negative 1 right here. I'm going to put 5 right here. And so negative 1, we got v is less than or equal to negative 1. I'm going to do a close point. Vector is going this way. And then right here, v is greater than or equal to 5. Close point, vector is going to the right. And that's not how a conjunction should look like. That's not how intersections should look like. So what this basically is saying is that this has no solution. There are no answers, because that word and, if it had the word or in there, then we can say, yeah, one of those is right. But and, it's impossible. Can a number be, is it possible for negative 2, for instance? Is negative 2 less than negative 1? Yeah. And greater than 5? No. Is 6 greater than 5? Yeah. And less than negative 1? No. So that is never, there's going to be no solution right there. That's just never, ever going to work. All right, for number 9, subtract 11 from both of these sides right here. That's 3c is greater than negative 9. Divide by 3. So we got c is greater than negative 3. And we don't flip the sign, because we didn't divide by negative. 9 is negative. The number that we divided into is negative, but what matters is the number that you're dividing by. That's what matters. All right, on this next one, we're going to divide by negative 4. So we're dividing by a negative on this one. So certainly the sign will flip here. So it's going to be c is less than 2. We're using the word or here. We're using the word or. I'm going to put negative 3 here. I'm going to put 2 here. And so negative 3, open point. The vector's going this direction. And for 2, an open point right here. And the vector is going this direction. And what that basically is doing right there is that is covering every single point on the graph. Because everything, if I were to shade this in, negative 3 on, go this way. 2 on in the other direction would go this way. So those overlapping each other, and it's not an intersection, but that's kind of what happens here. So this means this has all solutions. So if we write our answer, it's going to be negative infinity. Okay, keep doing brackets. We're going to do parentheses. Negative infinity to positive infinity, where it's all reals. The symbol for that is all reals. For the word problem right there, it says the set of teams with more than 30 playoff appearances and means it's got to be both, and more than 10 championships. So let's see here. Boston has more than 30, but do they have more than 10? They do. Okay. What else? 29. That's not more than 30. 32 right here for Detroit Pistons, but they don't have more than 10 championships. They only have 3. LA Lakers have 46, and they have 11 championships. So that includes that. And the Knicks have definitely more than 30 playoff appearances, but they don't have enough championships, only 2. I write this in set notation. We're going to say it's the Celtics, and we're going to say the Lakers. Basketball teams right there. All right, the set of teams with between 20 and 30 playoff appearances or fewer than 5 championships. Okay, so teams between 20 and 30 playoff appearances. All right, let's see here. Between 20 and 48's more. Chicago Bulls, it's that description. 18 isn't between, is between 20 and 30. 46 is not between 20 and 30. So it seems like it's just the Bulls, but there's another condition here. Fewer than 5 championships. So let's see here. Celtics have more than 5. The Bulls have more than 5. Cavaliers have less than 5. Pistons have less than 5. And the Knicks have less than 5. So we write this out. The Bulls, it's going to be the Bulls, Cavs, Cavaliers, Pistons, and the Knicks.